Hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to uh, any structural engineering concept that they are facing, or any doubts related to any structural engineering related issue, or uh, doubts from their projects that they are doing, or construction site related queries. And this is the 65th such episode that we are conducting. And let us begin by taking the queries from the Google form. So first we'll take the queries from Google form, and then we will take the queries from live audience and email also. So let us begin. So I'll just share my screen. I hope the voice is audible. Yes. So the first query is from engineer Mohammed Zayed. He is from Aligarh, Uttar Pradesh, and he is a working professional. His question is, and I think a similar query has been asked by similar query related to punching reinforcement has been asked by uh, engineer Suraj from Gurgaon. He is also a working professional. So I'll just put both the queries together and we'll try to answer them. So I hope the query is visible on your screen. So how to find shear reinforcement in foundation, either raft or combined, and how to provide in drawings as per requirement and as per IS code detailing rules. And this query from Mr. Zayed was, how do we take one-way shear and punching shear for a combined footing while designing in STAD using plate mesh? So I am not sure why you are using STAD plate mesh, because then it will not give you any results on its own. So if you are using, let's say, STAD, and if you have a combined footing, then manually you will have to first locate a, a section which is at d distance away from face of support. Over here you will have to check the shear uh, shear forces. Okay. Now I think the stat does not give you the shear force directly. As far as I remember, I don't use stat for plate elements because it's not very user friendly. But as far as I remember, stat does not give you direct shear forces. So I think it will give you shear stresses. So then you will have to look for shear stresses. Again, I'm not sure which direction of shear stress you need to look into. I will also have to check that. But you check for a shear which is, let's say, in plane in the gravity direction. Okay. So, for example, if I were to talk in terms of ETABS results, let's say if this is local axis 1, local axis 2, out of plane local axis 3, we would have checked for V13 shear, isn't it? And if I wanted to check on this uh, plane which is d distance away, we would have checked for V23 shear. Now, similarly, in STAD, I'm not sure which plate result to check. So I also need to look into, but there must be some output. I guess they write in terms of SXY or something. I'm not sure. So you check for those shear stresses because STAD will not give you shear force. So you check for shear stress, and then you need to ensure that it is less than tau C if you are using Indian code. So your tau V, which your STAD is giving you stress, has to be less than tau C. Otherwise, uh, you need to increase your thickness. And again, if you are wanting to provide, let's say, shear reinforcement from shear stresses. Then you check for tau v, let's say, in this d by 2 periphery, in a distance which is d by 2 in a perimeter, closed perimeter, at distance d by 2 from face of column. Now in this periphery, you check for tau v, then you multiply that tau v by, or why even multiply? Let this tau v be as it is. So this becomes your punching stress, and then you find out how much concrete can resist. So for that, you will require the uh, in fact, you can directly compare it with tau c, and tau c value is I think 0.25 under root FCK for Indian standards. So you can take this value and check for this. Uh, but again, which stress to check, I'm not sure in stat using plate meshes. I'm not sure. In ETABS, there is this value to check shear stresses also. There is an option to check shear stresses. So that gives you directly uh, the shear stresses in this closed perimeter. And I think you can just move your cursor around and look for it. So for STAD, I'm not very sure because I don't use STAD much for plate elements. I don't find it user friendly. Then this next query was from engineer Suraj, how to find shear reinforcement in foundation, either raft or combined, and how to provide in drawings. So as I just explained, if you want to find out or if you have decided to give the shear reinforcements, then you just find out, let's say you find out the shear force. Okay, yeah. By the way, there is in stat there is a option of section cut also, I guess. So when you use that section cut, let's say if you cut a section over here, then along this section and uh, along the depth, you do get some outputs in form of forces. So it's just like making strips in safe. You have this section cut option in stat. Although I have not used it, but there is this option that you can explore. Now, coming to shear reinforcement calculations, let's say you wanted to give a d distance away, you check the shear force over here, for example, Vu, and it will be this width. So let's say this is my section 11, which is having a width of this, and it will have certain d. So you have the Vu, you have the b, you have the d. You just find out the, and of course you will be able to find out the VC. So VU minus VC, for this you need to provide your stirrups, and just in your regular practice how you give stirrups you can give it. Now if you are providing for a shear which has direction of, let's say, if I was to use the ETABS terminology or safe terminology, and 3 is out of plane, so if I have to provide for V13 shear, then your shear reinforcements will be placed like this. So this will be your first set of bars, let's say. Then at spacing you will provide this, like this you will have to provide. So this will be your SV, this distance between these bars, these layers, this will be your SV. So this is your SV, and the summation of all the reinforcements, this is your ASV. Okay, so this is how you will provide for V13. And again, if you want to provide for V23, then you check a d distance away. Now on this section, then you will need to provide. So once again, these dots, so like this will be your ASV, and then the spacing between them will be a SV. So this summation of this together will be ASV, and the spacing that you provide between them will be SV. So this is how you will provide for one-way shear. Now for two-way shear or punching, you need to provide a closed, in a closed perimeter. So if this is your column, then you provide your, again first you calculate your VU punching shear. From that you subtract the VC, how much punching shear concrete can take. This will give you VS, and then from VS you find out let's say if you equate to 0.87 FI ASV, you find out the total ASV. That total ASV has to be distributed in the periphery, which is at d by 2 distance, remember, for punching. And then you will have to keep on providing it till your punching shear stress becomes half of tau c. So you can just read the clauses that are given in the IS code for the continuation of punching reinforcement. So it says that you have to continue providing the punching reinforcement till a distance where your punching shear stress becomes half of concrete shear stress. So till that distance, you need to keep on providing these punching reinforcements. This is similar to what we do in a flat slab. So I think, Mr. Suraj, you have already taken that course on flat slabs, where we have discussed this issue in great detail, and all the calculations also we have discussed. So the same process we have to follow for foundations also. Okay. Okay. So these were the two queries, similar queries that were asked. Now we move on to the next question. So next question is from engineer Rohit Kashyap. He is a working professional from Guwahati, uh, and he is asking, when modeling in SAFE, should we use the stiff element to model columns and piles while modeling pile caps? It affects the moments and shear force diagram significantly. See, if you are, let's say, if this is your, if this is your column, and if you model it as stiff, if you have modeled it as stiff, it becomes easy for you, because then directly you can check the moments at the face and shear at d distance away, whatever. So if you make it a stiff element in this region, you won't get any moments, etc., and it becomes easy for you to analytically just locate the section where you want to check the moments or check the shear. If you're not modeling it as stiff, then you have to on your own locate that section. For example, let's say you have not modeled stiff over here, then you first locate the center line, then you go, let's say you reach the face, then from face you go d distance, and then this is the distance where you need to check for shear, and then this is the face of the support where you need to check for moments. So you need to locate those. It, I mean, just by looking at the coordinates, you need to locate these sections. If you have modeled it as stiff, then it is easy, because you are straight away able to identify which is the face of your support, and over there you can check for moments. Of course, for checking shears, you still need to locate the section which is d distance away. So modeling it as stiff or not modeling it as stiff, it does affect the diagrams, movement diagrams. But remember that you have to check it at face of support or at d distance away from the support. Over there, the diagrams won't change or don't change. Okay. So the diagrams don't change at d distance. It is just that the movement diagrams you would see slightly different just below the support points, if you have modeled it as stiff or if you have not modeled it as stiff. In my opinion, it is better not to model it as stiff and let analysis happen, whatever is happening, and then you locate the sections which are at face of support, or which are at d distance away from face of support, or which are at d by 2 distance from face of support. Okay. Is it clear? All right. So in short, what I'm saying, do not model it as stiff, and you try to locate the distances or the sections where you want to check on your own. So this was engineer Rohit with his query. Then we have next question is from engineer Shaddesh Shirode. He is from Nashik, Maharashtra, and he is postgraduate student. So he's asking, when we apply temperature loads on beams, how is it as we apply temperature loads on beams in Celsius, how in ETABS internally it converts into longitudinal area, means how its calculations are done. See, basically, whenever you apply temperature loads, it calculates the strain. What is your strain? Strain is what? Delta L upon L. So this delta L is calculated as uh, your temperature delta T into this alpha. Okay, alpha delta T becomes your strain, and when you multiply it by L, it will give you the change in length, and this change in length, when you multiply it by, no, am I writing it correctly? The change in length will be your temperature coefficient into delta T. This is per degree centigrade into, I think, L also, yeah? Have I written it correctly? Just tell me. And then this change in length, so this is your change in length. So what will be your strain? Your strain will be alpha delta T. This, when you multiply it by stress, sorry, this when you multiply it by E, will give you the stresses that will be generated. Okay, and the stress when you get, or let's say if you have the strain differences in the strain itself, of course you will be able to calculate the internal stresses that are generated. So what your software does is, Mr. Ishan is saying divide 2. Yeah, oh sorry, for pile caps, correct, my mistake. Okay, yeah, I should have written divide 2 because they were saying for pile caps. Let me just make correction over here. For pile caps, for pile caps, for one-way shear, also you need to check a distance d by 2 from the face of column or pile, and for two-way shear also the same needs to be done. Yeah, just hold on. Yeah, so just make this correction in the earlier explanation. For one-way shear as well as for two-way shear, the distance remains d by 2. So whatever I said, even for one-way shear, if it's a case of pile cap, you need to check it d by 2 distance away. Other things remain the same. Oh, here it was. Yeah. So make this change and okay. So yeah, then okay, so once you get these delta L's, you just multiply it by the modulus of elasticity to get the stresses. And from stresses, then you calculate the internal, I mean, of course, once you get the strains, you can calculate the stresses or forces. And from there, you can calculate the reinforcement. So the software is able to do this calculation on its own. It will calculate the change in length from this alpha delta T into L, and then it will calculate the stresses, and from there it will calculate the forces, etc. So if you put the temperature gradient in degree Celsius, then this alpha has to be for per degree Celsius. If you are putting the temperature difference in Fahrenheit, then this alpha has to be in per degree Fahrenheit. Okay, okay. So the this alpha value, temperature coefficient, I think it's called, that value will change from whatever units of temperature you are taking. Next query is from engineer Ishan Desai. He is from Goa and he is a working professional. So he's asking, please analyze the counterfort on ETABS and please explain how to mesh the triangular elements. And he has shared one ETABS model. So I'll just show it over here. I'm not going to run the analysis in etabs. I'm just going to show you the screenshot. So this is his counterfort, and he's asking how to mesh the triangular elements. So for meshing the triangular elements, you can go to the elevation. So I don't know if you have made the grids or not, but you just go to elevation, and no, you have not made the grids. So you go to elevational view and make a grid line on this. Make grid lines such that these counterforts are on some grid lines. Okay. Then go to an elevational view. Let's say go to elevation on grid 3. So then you will see some elevation like this where you will see this triangle. Then you can make lines, just make some construction lines, okay, on your own. Construct those lines. Those lines preferably should be matching with these mesh that you have made on the retaining wall. So you make these lines and then mesh this triangular element over these lines, and then you can also divide them along this direction. So in this manner you can create triangular meshes. Oh, sorry, in this manner you can create meshes for your triangular wall. Then he had another query in double retaining wall. There are okay, so he had shared one more image, one more ETABS model rather, and it was a sort of a double wall. I was not sure why this double wall has been made. What is the purpose of having this double wall? So he has made this kind of a wall. The force, the retaining pressure, the retaining pressure is on this wall. The retaining pressures have been applied on this wall. So the back wall, I am not sure what is the purpose of making this back wall. But he's asking, his query is, uh, there are local stresses in the wall at the beam wall junction, which I'm concerned about. Is it possible to reduce the beams and transfer loads through slab itself by providing stiff elements? I have gone with shell thick for the middle slabs. What should be its depth to ensure the axial transfer of load through it? No, first of all, I'm not sure with this system why there is a double wall over here. I mean, you could have just made a frame. So you make a stiff column over here. Just let's say this is your make a column over here. Have this type of a frame created, stiff beams. This slab is also not serving any purpose for you. It's better to have a stiff frame like this. What I mean is, in elevation, let's say this is your retaining portion. This is your retaining wall on which there are on which there is a soil fill acting. Now you make a vertical column over here. Then at whatever distance it is allowed, you make this vertical column and then have a stiff beam attached to it. So instead of having a slab, this stiff slab won't help you as much as a beam element over here. A stiff beam element will help you, and it will just become a frame subjected to lateral loads, isn't it? It will just become a frame subjected to lateral loads. If you want, you may think of adding bracings also if required. If you're sure that the lateral load is going to be in one direction, instead you may add bracings like this so that they are in tension and your reinforcements can take those tensions. So this slab that you have provided and this back wall that you have provided, I don't think they are helping you, and they are just inefficient. Instead of that, my suggestion would be to make a stiff spine. So have these columns at the back. You can come up with some grid spacing, let's say at every 5 meters or whatever distance you want. you provide a column, a front column, a back column, connecting it with stiff beams. And along the height again, you can come up with some distance. And if you want to add these bracing elements. If you add bracing elements in this direction, they will be in tension. So you can put good amount of reinforcement to take care of that tension. Mr. Ishan is saying there are beams as well as slabs. Slabs convert the wall moments into shear. No, but what is the purpose? Slabs are not helping you. Replace your slabs by beams. And this double type of a wall is also not efficient. Instead of it, have stiff columns, have this front column, at the back have a stiff back column, and connect it with stiff beams. Imagine this to be a frame which is subjected to lateral loads. So what you are effectively doing, you are trying to, if you were to take a building analogy, you're trying to provide thick slabs to resist lateral load. It won't help you. You have to provide stiff beams and stiff columns. Okay. Yes. So do it this way and then see what happens. Okay. So then uh, next query is from Engineer Narayan Moduli. He is from Bhubaneswar and he is a working professional. He is asking regarding the wood armors method for plate stress analysis in StatPro. Could you please elaborate on how to determine the sagging and hogging moments in plates? I don't know. I mean, the software gives you that, right? I don't know the calculation for plates and shell stresses that go in the background. I can verify it with what is the expected value and whether your software is giving it. But I don't know how the maths happens for calculating the moments in plates from the plate and shell stresses. So better you read some text which gives you the maths behind it. Read some textbook. Okay. The analysis calculations, what happened in the background, I don't know how to calculate the moments from the shell stresses. Mr. Ishan is saying, can you please explain how to design the bracing? No, bracing, you put a bracing, you will get the forces. If you are putting this bracing in this direction, you will get tension forces. So for that tension forces, you just provide your reinforcement 0.87 FYAST. Concrete is anyway not going to work, so you just provide this reinforcement and you just provide this reinforcement, give it sufficient development length. Okay. Okay. Then uh, then yeah. So the next query is from Engineer Shiva. He is a working professional from Vishakhapatnam, and he is saying, in case of designing heavy vehicle stores, is it required to consider vehicle weight? Is it required to consider vehicle weight on plinth beam or not? If required, how to apply it as point load or UDL? No, so it depends on the type of vehicle. If it's a, I mean, if it's a truck-like thing, then technically it should be applied as point loads. But remember that exact point load application is also not correct because those tires have certain contact area, isn't it? So it's not a direct actual point load as such. It's a area load that acts. But then because the plinth beam width is small, you can apply it as a point load. Okay. But if you want to apply it on your beams, then better to have spring supports assigned below your beams to get a proper analysis result. So you assign spring support of your soil, okay, and then assign these loads. Generally, what we do is if there are plinth beams that are there and you expect heavy loads, then what we generally do is that we try to not give plinth beams right at the top, but we give it slightly below, and let's say have a 300 to 400 uh, soil fill over it. What I'm trying to say that instead of providing the plinth beam right at the top level, you provide it 300 to 400 below, so that over here then there is a soil fill, and that soil fill will help to not have direct loads applied on this beam. Is it clear? So this is a suggestion I can give you, that do not provide the plinth beams right at the top, have it slightly below, so that your beams are safe from direct point loads. Okay, then the next query is from engineer Vinayak from Bengaluru. He's saying, equivalent uniform moment factor as per clause this, what will these values for the column as per stat default value is 0.8, how to calculate it? I have attached the photo, consider that as the example for explanation. Most of the columns are falling under above clauses, and then he has shared one image. No, so right now I don't know what is the moment capacity of your column, what is the utilization ratio. It would have been simpler for me if you could have just double clicked and showed me the steel design output also in stat. From moments I cannot find out anything, because I don't know what column sections you are using, what is its section capacity, and all these things are unknown. Only thing I can see is uh, moments and their magnitudes. So this image alone is not very helpful, but I'll just show you the clause what you have highlighted, and you were asking about the CMX CMY. So I'm just looking in the code for that clause. So see, maximum most of the times column will fail under this combined interaction, because for combined interaction you have to check for the axial loads as well as the moments. So obviously this is the most common clause when it comes to your utilization ratio checks in STAD or steel members, so to say. So combined bending and compressions. Now how to calculate each of the values, we have discussed those in detail in our courses. So this is the sort of capacities. These are the analysis results, and these CMY, CMX are the moment factors as per table 18. And generally in STAT, the default value being taken is 0.9. So that is the default value it takes. If you want to replace it, you need to calculate it and give it as an override. And it depends on the bending moment diagram how you need to calculate. So this is the sort of calculation that is given. So for you, you will have to use this. This is the nature of your bending moment diagram. No, what is the nature of your bending moment diagram? Yeah. So here you will have to put your psi values between -1 and 1. So that means even for a double curvature, you have to use this value, and then you calculate it from here. If it's a uniform loading or concentrated loading, the formula remains the same. Psi value can vary between -1 and 1. So for you, it will be, this is, I cannot read the value, but it is, I think, 936 and 547. So if you write it as 936, this becomes minus 547. From that, you can get the psi and get the CMY and CMY or CMZ, whichever as per your local axis, and then do the calculation about the other axis also. So the columns will fail under this case itself because this is for the combined axial plus biaxial bending. Generally, it has been seen that these CM values come out to be lesser than zero point 0.9. So 0.9 is a conservative value. So your columns are not failing because of the CM values. They are failing because their moment values must be significantly higher as compared to their moment capacities. Okay. Yes. So these calculations we have discussed in detail in our course on steel design, these manual calculation, and stat does a good job for this. Okay. Yeah. Then the next query is from engineer Rohit Kashyap. He is a working professional from Guwahati. How do I calculate the wind forces acting in a member, truss, or dome structure where the wind passes through and load cannot be applied? So I'm assuming there is no cladding. What I'm assuming from his question is there is no cladding, and it's a bare frame truss or a dome. This is what I'm assuming right now from his question because he's writing where the wind passes through the structure. So I am assuming from his query, although it's not very clear, but my assumption I am making is that there is no cladding, and then he is asking that how to apply. So if there is no cladding and the wind is just passing through, then you calculate the CF factors, force coefficients, and those force coefficient will depend on the cross sectional of your elements. So for example, if you have a truss and let's say this is your top chord and whatever bottom chord and diagonals, and if it's a bare frame, that means there is no cladding, etc., then you calculate the CF based on the cross section. So if it's a angle, then there are tables given for calculate, I think it's table 29 or 30 or something, that depending on the shape you can calculate the CF, and then you multiply the CF by the exposed area of this member, and then you find out the wind forces. So this is how you will have to apply for these kinds of open structures. Okay. All right. So these were the queries that were asked on the Google form. Now let's have a look at the queries if they have been asked in the live chat. So Mr. Karthik Joshi is asking, how does torsion come into play for punching around the punching shear perimeter? Torsion, I don't know if torsion is considered in any manner while calculating the punching shear, but they do calculate the eccentricity of moments which adds to the shear. So if for example this is your column and this is your punching perimeter and this was part of your slab, whatever, then they calculate the moment imbalance, and from this moment imbalance they calculate the eccentricity of shear or eccentricity of moment which causes shear, and that gets added to punching shears. So then you write it as vu upon let's say PD plus the eccentricity, uh, and this gamma v is a factor which you use for calculating the portion of the unbalanced moment which is transferred to the column, and then this into, no, this into that, yeah, unbalanced moment into that eccentricity divided by some j polar moment of inertia values you take. Once you will take about the 2 2 axis, once you will take about the 3 3 axis. Okay, E upon J 3 3 and something like this. This is how you calculate the punching stress. So torsion, I'm not sure how torsions are to be included, but the eccentricity of moments which causes shear, this needs to be calculated. Mr. Karthik is adding, how does eccentricity of moment causes shear? I have seen in ACI which uses factor like JC which is related to torsion. No, so it's a polar moment of inertia. This J that is used is the polar moment of inertia calculation on this surface. Let's say if this was a column and this was being acted upon by unbalanced moments, then on this surface we will calculate that stresses due to the eccentricity, and on this we will calculate that varying stress, and to calculate this we use the concept of polar moment of inertia. So it's not the torsion per se, but it is the eccentricity of moment that is causing shear. If you want to get the details of this, we have discussed it in our flat slab course as well as the course in ACI concrete design that we are doing. But for if you want to know the maths behind it, you can refer to the book by Professor PC Varghese. He has given one. He has given solved examples. Even in Pillai Menon, they have explained this process. And in our courses also, we have done detailed calculations for this. Safe software does this work correctly, so you can rely on the outputs from safe software also. Okay. Okay. Then Mr. Chetan is from Bengaluru is asking why one-way shear is taken at d distance and punching at d by 2 distance. This was asked in interview. So the reason for this, that why we take shear one-way shear at d distance away and punching at d by 2 distance away has to do so for punching, so for one way shear, the reason is that the failure surfaces, when they did extensive testings, they found out that the failure surface where the shear cracks developed, that were making an angle of 45 degree, and because it was 45-degree, okay, because of this, they take the distance as d distance, so that this effective depth is d and this becomes 45-degree. So this is because of the dispersion angle or the distance at which they saw the failures occurring when in 60s they conducted a lot of actual testing, full scale testings. This is what they found out, or this is what they saw with respect to the failure plane for one-way shears. Similarly, for two-way shears, the failure plane was some 30-degree or something, 30-degree from the vertical, or I think some angle which uh, which sort of enabled them to take this distance as d by 2 for punching because of the failure surface around the column. When they analyzed those failure surfaces from actual testing, they could see that the uh, dispersion angle, or the angle where punching is happening, it forms an angle so that you can take a d by 2 distance away from the column. So these d by 2 and d distances are to deal with, or they are decided as per the actual testing that was done and as per the dispersion angles that were observed. Then Mr. Ishan is asking, what are some soil strengthening techniques that can be used to reduce the pressure? No, you cannot reduce the pressure. Pressure is pressure. It depends. Pressure depends on what are the external loads being applied. So you cannot reduce the pressure. You may be able to increase the capacity of soil. Okay. So you may think of adding piles, maybe. If possible, you can think of adding piles below. Maybe if load is acting from here, maybe add piles over here in compression. Here the piles will be under compression, so they are able to take that lateral load in a better manner. Or you can think of increasing this distance. In a way, you can increase this lever arm. If you increase this, then your forces will come down and your pressures will reduce. So you can think of these strategies uh, for your case. Okay. All right. Anything else? So we have taken all the queries from the Google form. We have taken all the queries from the live audience also. And let me check if there are any queries on the email. I think there were no queries on the email. Yeah, no queries on the email. Good. So any more query from our audience? All right. So I think there are no further queries. So the link for Google Form remains the same throughout the week. You can uh, keep putting your queries over here, and once every week when we meet, you can put your queries in the Google Form. Sorry, once every week when we meet, we will take up your queries. So this is the link for the Google Form. And if you want to connect with us directly on WhatsApp, then you can click on this link to connect with us on WhatsApp. So that's all for this session then. We will see you next week now with more queries and more discussions. So till then, have a good time, and yeah, see you next week. Bye bye.